hydrogen hydroxide ion concentration, what do you get? 2.3 times 10 to the negative 6. Remember, our log, we're taking the log of two significant figures there, which means we should have two decimal places. And what do you get, Charlie? 5.64. 5.64, that's right. Now remember earlier, okay, we have all our information. We have the hydrogen ion concentration, hydroxide ion concentration, our pH and pOH, okay? Now, suppose we use the fact that the sum of pH and pOH was 14.00. Well, let's see, if we know pOH then should be 14, subtract pH. And doing the calculation this way, notice 14 subtract 8.37, we get 5.63, and we do have a slight difference in our answers. Well, talk about this with your chemistry professor. He can talk to you more about where the difference is here, okay? Oh, very good. Now, let's do another problem. Now, in this problem, Charlie, we're given pOH is equal to 9.42, okay? Now, Charlie, we're going to calculate pH, we're going to calculate hydrogen ion concentration, and we're going to calculate hydroxide ion concentration, right? Okay, so here we go. Now remember that the sum of pH plus pOH is equal to what? 14. 14.00, so here we go. pH is 14.00, subtract, right? 9.42, that was our pOH. And what do we get for pH, Charlie? 4.58, very nice. So here, we have pOH and we have pH. Now we're going to calculate the hydrogen ion concentration and the hydroxide ion concentration, okay? But remember, let's talk about acids and bases, okay? Some of you might recall that a lower pH, okay, means that it's more acidic. Actually, if your pH is less than 7, what that means is you have actually a what, Charlie?
Acidic solution.
You have an acidic solution, okay? A pH of 4.58 implies that your hydrogen ion concentration is actually larger than your hydroxide ion concentration. So, again, talk to your chemistry professor about that. We're going to do the math. So here we go. Let's look at calculating the hydrogen ion concentration. And we're going to use the fact that pH is the negative log of the hydrogen ion concentration. Okay? Now, what we're going to do is multiply our equation there, both sides by -1, to give us the fact that negative pH is equal to the log of the hydrogen ion concentration. Now, this is a logarithmic equation. Now, what we're going to do is we're going to go from the logarithmic equation to the exponential equation. And here we go. The exponential form is negative pH is the exponent that you raise base 10 to get the hydrogen ion concentration. Sometimes this calculation is shown using something called the inverse log or the anti-log, but that's what it actually means, okay? And so, notice here, we know what the pH is. What is our pH, Charlie?
4.58.
4.58, okay? And if you take your calculator out and do 10 raised to the negative 4.58, Charlie, what do you get?
2.6 times 10 to the negative 5?
2.6 times 10 to the negative 5 molarity for your hydrogen ion concentration. Now remember, in regards to significant figures, okay, we used a pH to get our solution here. Now our pH was 4.58, right? Now 4.58, remember, that pH is actually two significant figures because it has two decimal places. If you remember what we talked about earlier, a pH is a logarithmic calculation. So the pH realistically only has two significant figures, and so when you go back and you take 10 raised to that negative pH, your answer should only have two significant figures. Again, that's something to look more into in your text and talk to your chemistry professor. And so there we are. Our hydrogen ion concentration is 2.6 times 10 to the negative 5, right, Charlie? Okay. Now, given that we have our hydrogen ion concentration, we can now calculate our hydroxide ion concentration. Well, first, we'll do it using our ion product constant for water. Remember, the product of the hydrogen ion concentration times the hydroxide ion concentration is always equal to 1 0.0 times 10 to the negative 14th. And so we can get the hydroxide ion concentration by taking our ion product constant and dividing by the hydrogen ion concentration. And so we'll do that. There it is, 1.0 times 10 to the negative 14th divided by 2.6 times 10 to the negative 5. And get your calculator out. And what do you get, Charlie, for the hydroxide ion concentration?
3.8.
We'll give you a little time here.
Wait,
Don't get nervous, Charlie. Start pushing those. Yeah, that's right. Start pushing those buttons. All right, Charlie, time's up. What'd you get?
3.8 times 10 to the negative 10.
3.8 times 10 to the negative 10. Molarity. Don't forget, moles per liter. Anyway, so now we have our hydroxide ion concentration. So we're basically done with this problem. But what we're going to do is we're going to again calculate the hydroxide ion concentration, but we're going to use the fact that POH is the negative log of the hydroxide ion concentration. What we're going to do is we're going to take that log equation, just like we did before, multiply both sides by -1, so we have negative POH is equal to the log of the hydroxide ion concentration, and we're going to take that logarithm equation and put it in its exponential form. And this is how it's done. We have a negative POH is the exponent you raise base 10 to get the hydroxide ion concentration. Okay? Now we're in exponential form, and so now we can calculate the hydroxide ion concentration by just replacing POH with its value. What was the POH, Charlie? For the last page it was what? Negative 9.4, it was 9.42, right? 9.42, so we get 10 to the negative 9.42 should be the hydroxide ion concentration. You take out your calculator. Remember that pH, 2 decimal places means 2 significant figures. Our answer should be 2 significant figures. So, all right, Charlie, put your calculator in. Tell me what you got.
3.8 times 10 to the negative 10.
3.8 times 10 to the negative 10th, molarity again, right? Now this time, notice, both answers are exactly the same, right? Okay, there was no difference here. Well, there you have it. There's your lesson on acids and bases, pH, POH, hydrogen ion concentration, hydroxide ion concentration. Boy, those are some tongue twisters. Anyway, be sure you do your homework, talk to your chemistry professor, and good luck in your classes.